Good morning. We have started with a series of lectures on operating system, where we have covered what is an operating system, then what are its functionalities, what are various components of operating system. This we already discussed. Now, under that, once we discussed what are the various components of operating system, what are the various management types which is to do, we have discussed. Then one of them is the process management. This is what we are going to cover up today. Now, in this particular series of process management, we are going to cover up what exactly is a process, how exactly once we say we are executing processes, we have to schedule those sort of processes. That means, which process has to come first, which has to come at a later stage. Then there may be some operations which are possible on the processes, then this is what we are going to do in our next topic. Then once we have got number of processes which will be executing on the system at the same time, we require some sort of a cooperation between those processes. So, that is what there is another major component which we have got as inter-process communication. Now, then we have got a finally, we have got a communication in the client server system. Maybe in the few series of a lecture, we will be covering some of these aspects. Now, initially we will start with what exactly is a process. Now, if I look at operating system that executes a variety of programs, maybe it is in the terms of a batch mode, there are number of jobs which we have put up for the execution, or they are in the shared mode, a time sharing mode, whereby each of these jobs is being given a time slice through which it has to execute that particular program there. We say these are the some of the user program or the task which we have to operate upon that. Then another aspect which is there is in most of the books, you will find this term jobs and the processes being used interchangeably. I may be using sometime I may be using tasks, sometime I may be using jobs. Basically these are the similar things. Now, initially let us start with what is a process. Now, once we are to execute an instruction on the system, we say every program, any program which is there, which is in execution, we say it is a process. Now, one of the characteristics of process is it has to execute in a sequential fashion, that is whatever process we have got, that has to execute in a sequential fashion. What do we mean by sequential fashion is, let us say I have got few instructions, let us say I have got an instruction, let us say A is equal to A plus 1, B is equal to B plus 1 and C is equal to A plus B. Let us say this is set of instruction which I have got. Now, once they are to be executed, I cannot execute this instruction first and afterwards this instruction. What I have to do is, this will be my first instruction, this will be my second instruction, this will be my third instruction. So, all the time we say once we have to execute any program or any process is to be executed, that has to be executed in a sequential fashion. Now, a process may include a program counter, stacks and the data section. Now, every process once it is to execute, obviously it will require some sort of a resources for the execution purposes, meaning thereby every process once it executes, maybe it is looking for a memory, then my operating system has to provide the memory to a computer, or it is looking for a hard disk space, then my system, my operating system has to provide him the hard disk space also, or it is looking for certain IOs, then my system has to provide it the IOs which it can be used at that particular time. Now, every process once it is in execution, it has to pass through a number of states. Maybe every process, the moment I start with the process, it is in the new state. Then once it start execution, it is in the running state, and once it is waiting for something to happen, that is in case it is waiting for some event to happen, then it is in the waiting state, or it is in the ready state, or it can be in the ready state. What do we mean by ready state is, it is quite possible I have got a process, everything is available to him, it has gone through IOs, it has processed everything there, but it is there on the system, but my CPU as such is not available to him for the execution purposes. So, in that particular case what we say is that this particular process is in the ready state, but since it is not getting a CPU at that particular moment. So, it remains in the ready state only, or it is in the terminated state, meaning thereby let us say my all the instructions which were there in that particular process only, they have been executed, and now once it has to be taken out of the system, that is what that state we call as the terminated state. Okay, that is the process has finished the execution. So, how do each of the states processes them? So, this is what we have got a process state diagrams. Now, initially each of this process is in the new state, that is the moment any process is created, all the time it will be in the new state there. Now, then it is admitted to the ready state, that means from here from the new state it goes to the ready state. Now, every process, this particular transition is only once, that means it is not that all the time I will be going from new to the ready state or ready to the new state. I will be going from new state to the ready state only once, and once it has gone to the ready state, then my scheduler or a dispatcher will send it for the execution purpose, that is from here it goes to the execution state, meaning thereby once CPU is available over there, now the instruction will start executing. This is what we call as the running state. Now, my process will remain in the running state till the time I got IO request. What do we mean by IO request? There are certain instructions, let us say there is a read instruction there. There is a read instruction, there is a read A. Let us say there is a this sort of instruction is there. I have to go for a read A, or I had to go for the write A. Then in that, or I have to read it from the file. Let us say star FP comma A. That is, it has to read this sort of information from some file there. Maybe I am using some sort of a pseudo codes only, it is not a language oriented things. So, I may be reading it from a file, that means this particular value has to be read from a file. So, all these are nothing but the IO instructions, and in this particular scenario my system will not remain in the running state, but it will go for the IOs there. That is what we say is it goes to the IO processor. So, this is what if my process it can keep on shifting from the running state to the IO wait state. The moment it is in the running state, it has it is executing a statement. The moment there is a read statement or a write statement, it goes to this particular IO processing there. That is, now at this particular stage it is not executing, but it has gone for that particular IOs input and output, and at that particular moment what happens is my system is idle, and maybe my IO processor may be busy at that particular time. So, what happens is my system, I am waiting for that particular IO to be completed. When does the IO completed? That means the number of data which we have to read from the hard disk, the number of data which has to go to the printer, till the time it is complete, it is in the waiting state only. Now, once this particular IO is over, that means this particular IO is over at what stage? Once my input and output is complete, then again it shifts from the IO state, this wait state to the ready state there. So, this is one sort of a transition which is there, which takes place in this particular process. Initially it starts with a new state, goes to the ready state, from the ready state it goes to the execution state, we call it the running state, and from running state the moment there is a IOs there is a need for a IO by the process, it goes into the waiting state, and again it goes back to the ready state. Mind it, it will never go back to the new state there. Now, this is one sort of a scenario which can be there, whereby it has gone for the IOs, or there can be some sort of a interrupt which can happen. That is, my process is in a running state, but suddenly there is some sort of interrupt which happens. So, in that particular case what happens is it goes back again to its ready state there. That means, there is some sort of interrupt which has occurred, and from the moment interrupt is there, once this interrupt is processed and it goes back to the ready state. Again it is the work of this particular scheduler, that is from the ready state, again once it has to go to the running state, it will be scheduled by this particular process there. That means, this particular scheduler will be making it to run over there. So, this is the transition which takes place. Now, and the third state which it can be from the running state is, okay, maybe from the running all the instructions which were there has over and it goes to the terminated state. Terminated state is, okay, the moment my process is over, then there is no instruction which is required over there to be executed, it gets into this particular terminated state. So, maybe these are all the states through which every process has to pass. Maybe from the running to the IO wait, running to the interrupt, running to the ready state, there can be so many transitions which can take place there, but as far as from the running to the terminated or from the new to the ready state, that will be only single transitions there. So, this is what we call as a process states. So, every process has to pass through this sort of a states there. Now, once it passes through each of the states, maybe from the moment it goes from the running to the waiting state, I may be executing the 10th instruction. So, what will happen to my 10th instruction? Now, what I had to do is, I had to store this sort of a value somewhere, so that my instruction can start executing from that particular state only. Now, this is what we have got. Okay, how do we create a process? Maybe it can be a new batch job. Okay, there is a process which is going to start, and this is what we call as a new batch job, or it is a interactive login. Okay, there is some sort of a login which has to be there on the system. Again, this process will be only once, or some services which are provided by the OS, that has to be initiated, or it is some sub processes which has been created by the earlier process there. So, what happens is, let us say I got a process A. Now, this may give rise to process B and process C, and this further can give rise to process E and process F. So, this is what we call as we just try to create this sort of a process there. Okay, process A, from process A I can go to the process B and process C and process E and process F. That is, during their execution phase, this process B and C has been created. Sometimes we call them as the sub processes. That is, these some of the processes which has been created by the earlier processes there. Maybe some of these processes can be executed along with this particular process, or this particular process may be suspended and this process may be executed, or both these processes can be executed in parallel. So, these are some of the scenarios which can be there for the execution purposes. Okay, I may be suspending A and executing C, or I will be executing A and C in parallel there. So, this is what we say is a process creation. Now, then next is, okay, once process has been created, it can be the termination of those sort of a processes there. What can be the reason for the termination? Maybe my instructions which were there, that is complete, that can be one sort of a scenario which can be there, or my processes were executing in a time sharing mode. What do we mean by time sharing mode? Okay, each of these processes are being given a particular unit of a time there. So, once this particular time is over, it has to be taken out of the system there, or memory unavailable, maybe resources which I am looking for, they are not available to me at a particular stage, or there can be some bound violations. Bound violation is, I am supposed to access a particular memory, I am trying to access some of the other memories there, or there is some sort of a protection errors which occurs, or there is a arithmetic error. What do we mean by arithmetic errors? Okay, there may be some division of a 0 which would have not occurred, that may make my process to terminate. Either in case of this arithmetic error, I may be having exception handling, or my process gets terminated at this particular stage there. Or it can be the IO failures. Okay, whatever IOs, let us say I am assigning some printer to my process, printer stops working, then what will happen to my job? Obviously, my job will also be not be able to execute at that particular stage there, or there are some sort of invalid instruction which has come up there. Okay, what happens is, okay, I am just having some sort of instruction, but there is one instruction which is invalid instruction there, or there may be some privileged instructions, that is whatever instructions I am thinking, that is reserved by the operating system, and I should not be executing that sort of instructions there, or there may be some sort of data misuse, that is my data which is assigned, that is of the wrong type, or my operating system that start intervene, that is for some reasons my process are being terminated by the OS there, or my parent can be terminated. This is a very interesting thing. Okay, let us say I have got this sort of a processes, and E. Let us say this is my state of the processes there. Now, let us say at a stage there my this process A terminates. Let us say this, in case this A terminates, what happens to my B, C, D, E? Because obviously, they were the processes which has to be executed as a sub processes for A. The moment this process gets terminated, obviously, this will have to be terminated. So, this is what we call as a, in case my parent terminates, then whatever are its sub processes, that will again get terminated. Or there can be another scenario, my parent says, let us say this process says, okay, I do not require this particular process, sub process, let this be terminated. That is what happens is, okay, this particular process D, it gets terminated the moment there is a request from the process B. Maybe these are two different scenarios. One is the parent termination. In case of a parent termination, what happens is, maybe this process is getting terminated, then obviously this process also gets terminated. Whereas, in this particular scenario, in case the process B requests, okay, my process D should be terminated, then obviously this process gets terminated there. So, these are the two different scenarios which are there, which we call parent termination or the parent request there. Or my process can be in the suspended state. What is the difference between suspended and a terminated state? The moment I terminate a process, then no longer in a subsequent time limits I can execute that particular process. Whereas, process suspension is, okay, this can be scenario for a process suspension. Okay, the moment my process B start executing, the moment my process B start executing, then my process A gets in a suspended state. So, let us forget about termination. Let us talk about the suspension. Okay, what is happening? The process B is executing, and in this particular case my process A is remains in the suspended state, because it is waiting for the process B and C to be completed. Or my process B can be in the terminated state or suspended state the moment my process D and E are to be executed. So, this is what we call as a process suspension. Now, what happens afterward? The moment this process execution is over, then again the process of execution of this particular process starts. That means, this particular suspended process is revoked. Now, it can be, as I said, reason for process suspension is there is some sort of swapping which is taking place in the memory, or there may be other reasons. The operating system may suspend a background or a utility process. That is, what happens is my process is running in the background state and suddenly I have to suspend this particular process, or it is a interactive user request. My process is executing in a interactive fashion. What do you mean by interactive fashion? First of all, system gives you some input, then I responds back, then again system gives you input, I responds back. So, in case I am executing in this particular process and my user is not inputting the data there, then again in that particular state my process remains in the suspended state, or it can be the timing. My process may be executing periodically, that is based on some sort of a monitoring process it has to execute, and it is waiting for some time interval before it again starts, or my parent process request. Now, this is most important. My process can be in the suspended state in case my parent says you keep this particular process in the suspended state here. Now, we have discussed about process may be in the new state, it can be the ready state, it can be in the running state, it can be in the termination state. So, these are some of the states which are there for the process. Now, let us say I am having a process which is executing, suddenly you take it for the IOs. Let us say I am at the 10th instruction, I had to execute the 11th instruction at that particular moment. So, what will happen to my execution? That is, let us say I have executed 10 instruction, out of that there may be some intermediate values, there may be some file uses which may be there. So, what happens to that? So, this particular where does this information is kept? Now, we have got a separate block which we call as a process control block. So, that is all the information which is associated with the process, that particular information is kept in a block which we call as a PCB. Now, what sort of information is associated with each process? What is the state of this process? What is the program counter? Process state is whether it is in the execution state, whether it is in a suspended state, or program counter, how many instruction has been executed at a particular moment, and then the CPU registers, that means what are the register which has been allocated to my process there. Because obviously, in case let us say I am executing my process in time sharing mode, there may be 10 processes which are executing, each one has maybe having its own register through which it is processing. So, all this register information has to be kept there, and CPU scheduling information. What sort of a priority I have got for my process? My process may be a low priority job, my process may be very high priority job, or maybe process may be only middle priority job. So, all sort of a scheduling information is kept in case in this particular PCB there, and then memory. Let us say if I look at my memory only, let us say I got a process which has been allocated some memory, maybe this is the memory map which we have got. Let us say this is my operating system and this is my process 1, this is my process 2. So, what we say is this is the maybe lower limit of my memory and this is my upper limit of the memory there. What do we mean by that? This is the amount of a memory which has been allocated to this. Let us say this start from the location 5 to let us say 400. Let us say this is some hypothetical values which we have got. Maybe my program has got a lower limit of memory is 5 and upper limit is 400. Now, all this particular information, upper limit, lower limit, what sort of allocation is there of the memory is being kept in the PCB there. Now, all sort of accounting information. By accounting information, how much, let us say my system is such, it is a commercial system, whereby I had to find out how much CPU time I had taken, how much memory I had taken, how much printing I had taken. So, all this information is kept in this particular accounting information, and then another is the IO status information. Okay, what sort of a devices has been allocated to this sort of a process. My process may be allocated printer, it is the allocated tape drive. So, all this information is kept in the IO status there. Mind it. So, this PCB is the most important component for the execution of the process there. So, every time we say we are loading our process, we are loading our PCB block there. So, at every intermediate stage, I am loading my PCB for the execution purposes. So, this is how my process control block look like. Okay, it has got a pointer. Now, this is the pointer through which I link to the other process blocks there, and this is my process state. Okay, at a particular stage, what is the state of my process, whether it is a ready state, execution state, or in the new state, or in the terminated state. And then we have got a process number. Maybe in case my operating system is giving some sort of a numbers there, it is taking care of those sort of a numbering there, or it is having the program counter. Okay, it is which instruction is getting executed on my system there. So, this keeps track of this sort of a system there, and what sort of a registers has been allocated there. Okay, maybe my process is being allocated some registers there. So, this information is kept in the registers there, and memory limits. As I explained to you, okay, this is what we have got, the memory limits, lower limit and the upper limit, which has been allocated to this particular process here. And another very important thing is the list of open files. Maybe once my process is executing, it may be having number of files, which is it has open for the execution purposes. Some of them may be read files, some of them may be the write file. So, what are the various files which has opened, and what is the position of those sort of files? By position we mean, let us say I have read the 10th record. So, if I am in the 11th record, that particular position will be kept over there, or I am writing a file, then in that particular case what will happen? I will be having the write pointer, through which this sort of information will be kept over there. So, all this is the most important component as far as the execution of any of the process is concerned, because obviously for any execution I had to keep track of this sort of a PCB block there. So, every process, once any process is to execute, it will first of all it will create this sort of a process block. Now, let us say I am going to the IO wait state. It's then in that particular case this particular PCB will get into the queue, because if I look at once I say it is a ready, I may be forming a ready queue there, in case there are more than one job which is there for the execution purposes. Now, how does execution takes place? Let us say these are two processes which are there. I have got process P naught and I have got process P 1. What is my process P naught? It is some process which has to be executed there, and there is another process P 1 which has to be executed there. Now, execution cycle for both the processes starts. Now, let us say there is this maybe P naught is executing, P 1 is executing. There is a state that the moment there is some sort of interrupt which occurs, there is some interrupt given by the system that this process has to stop. The moment I have got this sort of interrupt, this process has to stop, then all this information, there will be separate PCBs for each of this process, and my state will be saved for P naught process in the PCB 0 block there. Now, then what is the next which is happening? Now, at this particular stage up to this till the time my reloading of PCB 1 takes place, this particular process will remain in the idle state. That means, at this particular time no process is executing. I reload PCB1. What does it mean by reloading the PCB1 there? Okay, whatever are the program counter, whatever are the open files, all this information which we have kept in the PCB, that will be loaded into the system there. Now, the moment this has been loaded, now this particular process will start execution. Maybe this is what is happening, okay, this process P1 is getting executing in this particular timing diagrams. Now, again there is a some sort of a interrupt or a system call which happens to this particular process P1. There is once P1 is executing, there is some sort of a call for this, okay, you suspend this particular process at this particular moment. Now, once this sort of a call is there, okay, you suspend this particular execution of this particular process. Now, what I do is again I save this particular information about this particular PCB, about this particular process into the PCB1. Now, mind it, that is what you have to see, okay, as many number of processes has been created, that many number of PCBs will be there. Okay, it can be PCB0 and PCB1 which will be storing this particular information there. Now, once PCB execution for PCB1 is over, then again the execution for PCB0 will start. That means, up to this particular time, this particular process has remained idle there, and now it again reloads the state from the PCB0, PCB0, it loads the state of the process PCB0, okay, whatever the state of the process PCB0, it loads that particular state and again it starts the execution of this particular process. Maybe this cycle repeats for all the processes which are there in the execution state. Maybe my processing is done in time sharing mode or it in the multi processing mode, but this sort of a system will remain there. So, this is what we call as a switching from one process to the other. Okay, what is happening in this particular state is my CPU, my processor is switching from processor P0 to P1, and in case there are more than one process there, then maybe it is shifting from P1, P2, P3 and P4. Like this, it keeps on shifting from one process to the other process for the execution purposes. Maybe I can repeat, what I am doing is I am executing process P0 and P1. Once P0 is executing, P1 is idle, and once P1 start executing, I had to save the state of this process P0 somewhere, that is being saved in PCB not, and once my process P1 is executing, my P0 is idle, and moment my P1's execution is over or suspended, again it has to switch off from that particular state, and then again I will be loading the state of the PCB not there. So, like this sort of a cycle will keep on moving for till the time up to what time this sort of swapping and other things will happen, till the time execution for either of the process is over. Then maybe in this particular case, then only one process will be executing at that particular moment there. Now, if you look at once we have got a number of states for the process, there may be number of queues which will be following for each of the sort of a process there, that we call as a process scheduling queues. What is a scheduling queue? The moment my process is to be executed, there will be some queue which will be formed for this sort of a process. Let us say you talk about the new, maybe there may be 10 new processes which has been created. How do I execute those sort of process? There must be some mechanism whether which process is to be put into the ready state at what time. And once my process is in the ready state, let us say there are 3 processes which are there in the ready state. What will happen to those processes? My processor, my system can execute only one process at one time. So, what will happen in this particular case? The next process will be put into the queue. Now, the moment that will depend upon what sort of a scheduling I have got. Idea is I should be able to execute maximum number of processes there, but that is how it keeps on following this sort of queues. Now, what is the state of my process once is in the ready queue? It is there in the main memory and it is waiting for the start of the execution there. Now, then afterwards it can be the device queue. What is the device queue? Let us say I got a printer. There are 3 jobs which are ready for the execution purposes. Once it is ready for the execution purposes, there it will be in the only my device can take, let us say, only one job, then rest of the 2 jobs will remain in the queue only. So, this is what we call as the device queue. Mind it, for each of the device there will be a separate queue, meaning thereby let us say I got a printer, I have got a tape drive, I have got some other devices there. My printer will have a separate queue, my CPU, my tape drive will have a separate queue over there. And another aspect is that this particular processes, they keep on migrating from one queue to the other. Let us say initially it was in the new queue, then it has gone into the ready queue, from ready queue it may be going to the device queue, and this sort of a interchanging will migration will be there for each of these processes there. Now, where does this queue gets formed? Who forms this queue? Now, there are certain data structures which are being used for this sort of a work. Maybe one of them is the linked list, whichever is the there in the header node, which is being pointed by the header node, that process will start at the execution state. Mind it, it is your PCBs which are getting into the queue. So, everywhere let us say this is my queue header which is there, and this is how my queue is formed. Maybe for each of this, let us say this is my magnetic tape queue and this is my disk queue and this may be my terminals queue. As I said, each of this system, my operating system is such that for each of the device it makes a separate queue over there. Now, as far as data structures are concerned, based on my scheduling algorithms, there is some sort of a data structure which is formed over there. Maybe as I shown you, it can be just a linked list. By header list, I may be linking all the PCBs which are coming over there. So, whichever PCB has come first, that will be there for the execution state. Now, how do we represent this sort of a process scheduling? Initially, each of this job is in the ready queue. Let us say every process is in the ready queue. Now, the moment it is in the ready queue, from the ready queue, the moment it gets a turn. Now, who decides, who will, which process will be going? There may be some sort of a process scheduling algorithm which will be there. Now, there may be some sort of a algorithm through which I decide which is the process which I must execute at this particular moment from the available jobs which are there in the ready queue. Now, it goes into the CPU and the instructions start executing. Now, what can happen? My process is over and it goes out of the CPU, that is it has been terminated and goes out of the CPU there. This can be one state which can be there, or there is some sort of a IO request which comes up there. There is a IO request here and it again goes into the next queue. The moment there is a IO request, it goes into the IO queue for that particular IO device. Now, once this particular IO processing is over, again it goes back to the ready queue. So, mind it, every time the job, every time it is taken out, again it goes back to the ready queue here. Or another is my time slice expires. Let us say my job is executing, but suddenly let us say it has been allocated only 5 units of a time. Since this 5 units of time is over and my time slice is over, then again it is swapped out of the CPU here. Now, once my time slice is over, but still I am in the ready state, because it is not due to some other reasons of my process, my suspension is there. It is due to whatever time my CPU has allocated, that particular time is over, it has to go out of it, but over here it does not do anything, straight away it goes back to the ready queue. That is, at this particular stage it is not to do anything at this particular stage, but straight away it has to go to the ready queue here. Now, or what happens is, okay, there is a new child which my process creates. That is, what happens is, as I shown you earlier, okay, there may be some process, what is a fork a child, okay, let us say this is a process A, B, C, D and E. Let us say this is the state of my processes. Now, let us say this is A is executing, suddenly there is a need for it to create a child process is there. Now, in that particular case what will happen, maybe this particular process B will start execution and this will become in the suspended state. So, this is what we say is the forking a child process, and then the child process starts execution, and at that particular time my parent process is not in execution, but it is in the suspended state there. Now, once this particular child execution is over, again it goes back to the ready queue here. So, every time its work is over, it goes back into the ready queue, or there is some sort of interrupt which happens over there. Okay, there is some sort of interrupt by the CPU. Due to that particular interrupt, my process has to be taken out of the CPU there. Now, the moment this interrupt occurs and this moment this particular interrupt is processed, again it goes back to the ready queue here. So, this is what we call as the process scheduling. Now, who does all these sort of things for you? This is there some sort of a mechanism we call as a schedulers, who does all this sort of a things for me. Okay, let us say from the ready queue, what are the job which has to be taken to the CPU for the execution? It is to be done by my scheduler, and the moment there is job has gone out of the IO request, again another job has to go to the CPU, again it is the scheduler who decides which are the job which has been taken to this particular system here. And we have just discussed about the need for a schedulers. Now, it can be a long term schedulers. Long term scheduler is, okay, I have to take the decision what are the job which I have to execute. Let us say there are 20 job which needs execution, but I select only 5. Okay, these 5 jobs I will be taking to the main memory there. So, in that what happens is, this is what we call as the long term schedulers. Okay, this is the scheduling, or we call as the job scheduling. We select which process should be brought into the ready queue or in the main memory, and short term scheduler is, or we also call it as the CPU schedulers. Okay, select which process to be executed next and which is to be allocated CPU. Maybe if you look at my long term schedulers, they may be taking a very less number of decisions as compared to my short term scheduler, because every unit of a time my CPU is idle and I have to put some job for the execution purposes. Now, since this particular job long term scheduler and a short term schedulers, there is something in between which happens, we call it as a medium term schedulers. Medium term scheduler is some scheduler which is intermediate to the between long term scheduler and a short term scheduler, which does some sort of other scheduling jobs. Now, this is how my process may be in the ready queue, it goes to the CPU, it is swapped out, and there may be partially executed swapped out processes, and again that has to be swapped in. So, this maybe it is my medium term scheduler may be doing this sort of jobs for me, or it is the end of the jobs, and there can be some sort of IO jobs which are waiting over there, because these are the 3 states which can be there. Either it can be the swapping out of the job, or it is the end of the job, or it goes for the IOs. Now, my medium term scheduler can decide, okay, out of this particular waiting at this particular stage or at this particular stage, what are the jobs which are to be taken into the ready queue first. So, this is the addition of the medium term scheduler which we have in case we are to schedule our processes there. So, that is what we say schedulers. My short term scheduler is invoked very frequently, maybe it is in terms of the that is why we say my short term scheduler must be very fast, because in case my scheduler is slow, then obviously it will give rise to more CPU time wastage there. And a long term scheduler is invoked very infrequently. Okay, that is very rarely we are invoking this sort of a long term schedulers there, maybe in terms of seconds or in terms of a minutes we are scheduling each of the job, and this may be very slow. This sort of a scheduling may be very slow, because long term scheduling they decide about the multi-programming there. What is the multi-programming? How many out of the job which I am trying to execute, how many jobs I will be taking for the execution there. Now, I can describe my jobs as a CPU bound jobs or the IO bound jobs. What is a CPU bound job? Okay, most of the time it takes for the execution of the process there, and IO bound job, okay, most of the time it spends in taking care of the IO, that we already discussed. Okay, my jobs can be IO bound job or it can be a CPU bound jobs. Now, once we are to switch my job from the CPU to the memory and memory to the CPU, that particular process we call as a context switching. That is, once CPU switches from the other processes, what is the system has to do? It has to save the state of the old process and load the state of the new process there. I think this is what we already discussed. Okay, it has to load the save the old process state and load the new process state over there. This sort of a process we call as a context switching. Now, once context switching is taking place, at that particular moment my system is not doing anything worthwhile vis-a-vis my process is concerned, but this we take it as a overhead for my system there. Maybe context switching, loading one saving the state of one process, loading the state of the other processes, we call this particular thing as a overhead for my system there, and in this particular state it is not doing anything worthwhile while it is going for the context switching. So, this is what we have discussed. Okay, we have discussed about the various processes which are there and what sort of a resources are required for the execution of each process, and the states of these processes, and for the need of the process control block. Because once we say process is there, obviously it requires some sort of a resources, maybe as we discussed in terms of CPU, in terms of the IOs, in terms of the memory, or then it has got its own states of the processes, whereby we discuss the need for each of the states and why process gets into each of the states there. Maybe my new state is there, ready state is there, or the wait states are there. These are some of the states which are there, and since we have to keep this sort of information there, we need the process control block for this particular aspect there. Maybe we stop here. Thank you.